The Tarim Desert Highway shelter belt, located in the hinterland of Taklimakan Desert, is irrigated by underground saline water with 3 to 30 gram per liter mineral degree. The sustainability and stability are affected by multifarious stress. The structural and functional characteristics of shelter belt are studied to probe into correlation between environment and shelter belt. On basis, decision analysis is applied to study ecological stability of the Tarim Desert Highway shelter belt to screen out limited factors to establish general index system and to evaluate the stability of the shelter belt nowadays. Finally, the concept of ecological stability is utilized to manage the artificial ecosystem. The temperature and humidity of the shelter belt microclimate on both horizontal and vertical scales in the extremely drought area were measured with multiple ISO-BO temperature and humidity automatic observation equipments in the hinterland of the Taklimakan Desert. The shelter belt significantly influences the environment, and the microclimate in the belt has an obvious characteristics of cooling and humidification. Compared with original sand area, the temperature in the shelter belt is always lower and the humidity is always higher. Moreover, the temperature range at the shelter belt edge is greater than that in the sand area, but the humidity is always higher. The Tarim Desert Highway shelter belt crosses the hinterland Taklimakan Desert for nearly 550 kilometers. The highway was built between 1993 and 1995 to access the region's vast oil reserves. First, the highway was bordered by only a sand casing checkerboard mesh of straw in order to protect the road from encroaching desert sand dunes. After years of testing, more species were introduced. According to the People Daily, some 2 million rose willows, saxhole, buckthorn were planted along the highway in 2001 alone. They were chosen from 50 tree varieties after a decade of experiments that showed that trees with small leaves and a maximum height of 2 meters proved the most suitable for life in the desert, as they lose moisture slowly and are resistant to arid conditions. The artificial forest of the shelter belt is irrigated by underground saline water containing 3 to 30 milligrams per liter of mineral degree. In a 2006 research, the shelter belt was studied for its ecological stability in order to better manage the artificial ecosystem. Results show that the artificial ecosystem is relatively flimsy, but its stability can be increased by adjusting stand structure and improve the nutrient cycle. The result shows that the wind speed and sediment transport in the shelter belt decreased by 64% to 99%. The soil bark density decreased while soil porosity, salt content and water content increased when compared to natural mobile sand. The soil's fertility improved fast rapid than slow. Microclimate effects up to 6 m above ground level were positive. No significant effects of groundwater pumping and forest irrigation water were found on the groundwater level and its salinity. Freshwater resources are scarce in desert regions. Highly saline groundwater of different salinity is being used to drip irrigate the Taklimakan Desert Highway shelter belt with a double branch pipe system controlling the irrigation cycle. In this study, to evaluate the dynamics of soil moisture and salinity under the current irrigation system, soil samples were collected to a 2-meter depth in the shelter belt planted for different years and irrigated with different groundwater salinities, and soil moisture and salinity were analyzed. The results showed that both depletion of soil moisture and increase of topsoil salinity occurred simultaneously during one irrigation cycle. Soil moisture decreased from 27% to 2.4% for a 15 days irrigation cycle and from 26 to 2.7 for a 10-day cycle respectively. Thank you.